Welcome to Everything Explained. I'm your host, and today we're diving into a question that sounds almost like magic: why AI can spot patterns humans can't see. In the end, it isn't magic. It's math, data, and a different kind of attention. Humans are great pattern detectors, but we have limits. We can notice patterns in faces, in music, in trends we've seen before. But when you tilt your head to look at a mountain of data, millions of photos, speeches, sensor readings, the patterns we miss aren't a sign of laziness. They're a sign of cognitive bandwidth. There are simply too many dimensions for a person to track at once. That's where AI comes in. Modern AI, especially deep learning, uses neural networks with many layers. Each layer learns to represent the data a little differently. Early layers might notice simple things: edges, colors, textures. Deeper layers start combining those cues into more complex ideas: faces, objects, moments in time. The final layer then matches those ideas to a label like cat or defective bolt. It's a chain of feature detectors, each one building on the previous, able to summarize patterns across millions of examples. Training is key. The system doesn't know what to look for until we show it lots of examples. If we show it pictures of cats and dogs, it starts to pick up on subtle cues that separate them. It's not just one cue, it's a web of cues that, taken together, paint a picture the human eye might miss. Think of a detective tracking a thief across a city. You might not see a single clue, but a pattern of small signs, shoes left prints, a particular route, that point toward the truth. In AI, the clues are pixels, language tokens, or sensor readings, and the pattern is distributed across the whole network. Language models work the same way, just with words and syntax. They learn that certain sequences of words tend to occur together, and from that they can predict what comes next or generate a paragraph that seems coherent. In science and business, we use AI to find patterns in climate data, in financial transactions, or in medical images that human specialists would take longer to notice. Here's a concrete medical example. Doctors read chest X-rays and look for obvious signs. An AI system trained on thousands of X-rays might flag a subtle pattern associated with early pneumonia that even a seasoned radiologist would miss in a busy shift. It's not that AI knows what pneumonia is in a human sense. It has learned correlations that point to it. When used to assist doctors, it can speed up detection and give humans a second pair of eyes. Why can't humans do this alone? Our brains are excellent at generalization, but we're limited by attention and memory. We can only juggle a few things at once, and we rely on prior experiences to interpret new data. In a data lake the size of the internet, invisible patterns hide in combinations no single human would consider important. AI can comb through those combinations relentlessly, 24/7. Of course, there are caveats. AI loves correlations, but it doesn't understand causation. A model might latch onto a spurious cue, like a watermark in images from a particular camera, then fail on data from a different source. Models can be biased if the training data isn't diverse, and sometimes the patterns are true in training data but fail in the real world. The famous term is distribution shift. The world changes, and models stumble. That's why researchers pair AI with humans. We use techniques to interpret what the model is paying attention to, like heat maps that highlight which parts of an image mattered, or methods that estimate how much we should trust a particular prediction. We also keep human experts in the loop to validate and guide decisions. And we continue to improve data quality, test on varied scenarios, and design models that can explain their reasoning in plain language. So, why do AI detect patterns humans can't see? Because AI doesn't see like we do. It processes vast high-dimensional data through many layers, learning to recognize complex cues that don't stand out to the naked eye. It helps us by surfacing clues, speeding up work, and sometimes revealing things we wouldn't spot on our own. But it's not a replacement for human judgment. The best outcomes come when we combine machine pattern finding with human wisdom, curiosity, and accountability. If we stay curious and careful, AI isn't here to eclipse us. It's here to extend our vision and help us ask better questions. That's the power of AI, noticing what we miss, and inviting us to see the world in a smarter way.